Okay, we had already done this problem, so we're going to continue with graphing, looking at amplitude and period change on the sine and the cosine. So we're only going to graph sine waves and cosine waves right now and explore amplitude and period changes. We can say that if a is a positive number, then the graphs of y equals a sine x and y equals a cosine x will have an amplitude of a. Amplitude is always positive. All right, now it's the number a could be negative, but amplitude is always a positive number. When you give the amplitude, you will answer with a positive number. So graphing y equals 3 cosine x. This time the amplitude is 3. And what's the period for the cosine wave? How long does it take for the cosine to continue a cycle or repeat a cycle? Once around is the unit circle. You better know. You're going to be quizzed on the unit circle tomorrow. 2 pi units. It does it every point is different in each quadrant, correct? And then until you get 2 pi, you don't repeat the cycle. All right. So the period is 2 pi for both the cosine and the sine. Now we graphed these last time. Okay, so we want to graph a cosine wave with an amplitude of 3, meaning it stretches instead of maxing out at 1, it goes all the way up to 3. Now I'm just going to label basic things on these little these graphs. If you wanted to mark off, 1 and 2, you could have, but I'm not going to take off if people don't. I just want you to know it goes up to 3. The normal cosine wave stays within a range of 1 and negative 1. Okay, so you are required to graph 1 cycle, and 5 key points along that cycle need to be labeled. If your graph is asking you to go past 1 cycle, you'll know, and you'll just, like this one, we might be going past this. We're not going past the cycle because it's from 0 to 2 pi. This one didn't specify, so I would expect 1 cycle. All right. Period is 2 pi. So don't make a mark here and then try to make this teeny weeny graph right there. Go ahead and stretch it out. So I'm going to go out here to 2 pi. And that was a slash. I don't know why I made it so big. It's just a tick mark, whatever. Now I'm going to cut this x-axis up into parts. If the first point is 0, 0, it might be 0, 1, or it's 0, 0, or depending on if it's sine or cosine, I need to cut this up into some equal parts. I'm going to cut 2 pi in half, and I'm trying to estimate halfway between 0 and 2 pi. So that would be pi. And then half a pi, I'm going to cut that section from 0 to pi in half. That would be pi over 2. And then that means my x scale is, and I'm going to cut this section in half, and I got to label it. So I say, well, my increments are 1 pi over 2, then I go next to 2 pi over 2, then the next one would be 3 pi over 2. And that's how you should be thinking on your unit circle when you label it tomorrow. All right, and now those are my 5 key points I need to have within a cycle. I need to label them now, find those 5 key points, and graph the cycle. So it's a cosine wave. At 0, we need to memorize cosine is 1 normally, but this thing's been multiplied by 3. So it's actually starting off up at 3. The cosine of pi over 2 is 0. 3 times 0 is still 0. At pi, the cosine is negative 1. But we multiplied it by 3, so it's going to be negative 3. And to go back to 0 at 3 pi over 2, and then at 2 pi, the cosine's 1, but we multiplied it by 3, so we're up higher. So now I'm going to sketch the cosine wave, and you need to make sure it's curved. We need to talk about what's going to be acceptable and what was not acceptable as far as what you graph. Everybody's not going to be perfect at making these curves. But let's just say, and I can erase this in a second, If your graph looks anything like this, you will have points marked off. Yes, it's not a V, guys. It's curved. That will not count for a good graph. And things like this wouldn't be okay either. Okay, you see what I'm saying? Like, it needs to be curves that are going in the correct direction. All right, get the idea of what the shape is. All right, we need to label these key points. So the first one is 0, 3. The second one's pi over 2, 0. The third one is at pi negative 3. And the fourth one's at 3 pi over 2, 0. And the last one's at 2 pi 3. Okay, y equals 1, oh, we're going to graph now y equals 1/4 sine x. Well, to get an idea of actually what's gone on, the amplitude here is 1/4. So that is flattening the graph. Whereas the last one, the amplitude of 3, stretched it vertically by 3 times. This is shrinking the graph by 1/4. Right? The period is still 2 pi because it's a sine wave. We're going to graph one cycle. We're going to go from 0 to 2 pi, so that's going to be just one cycle. Oh, wait. So normally it goes up to 1. So if that's 1, then 1/4 is going to be pretty darn flat. I don't know why I just made 1/4 there, but that's good enough. You know, it's like cutting it in 1/4. I don't know, these aren't perfect, but let's just label this negative 1/4. And I'm not going to keep on labeling everything every time. I want you to have an idea of what's actually happened to the graph right now. It's shrunk, okay? You will have to have the labels correct, but will you have to show one? I'll tell you what, a lot of the graphs that I give you are already drawn, so you can do it nicely. I mean, you're not just doing blank ones like this. We have a quiz where you will have to fill in something blank like this, and I just expect to see the key values. All right, and so cutting 2 pi in half is pi. So get the same labels on as the last one on the x-axis. Okay, now this is a sine wave. The sine at 0 is 0. The normal cosine graph, would go up at pi over 2 all the way to 1, but this one only goes up to 1/4. And then it goes back to 0 to negative 1/4 and back to 0 at 2 pi. So it's really flat, but it's still a curve. Make sure it's curving. Yeah, so make sure like your parabolas had to be curved. They were not V's. That was your absolute value graphs. Anybody need me to stay here while we're... Okay. We did this one the other day. We talked about the period change, and that was if the number in front of x is not 1. So let's graph this one. Example 5 on your paper. We've got a period change because of the b value. This says y equals sine bx. Oh, a little reminder, to find the new period, you take the old period of 2 pi and divide by b. So the period here is 2 pi over, I guess I should have written b there. 2 pi over 3. It's telling us to go from 0 to 2 pi though. So if it's 2, this right here, this 3 has just cut the period by 1/3, which means how many waves would be within it? Okay, it's like 3 times the waves. So we're going to need to go, if we're going to do out to 2 pi over 2 pi units, we're going to have 3 waves. So let's just cut this up like this. We'll do a 2 pi over 3 here. And then cut that, and then we'll go to the end, and we're going to say that that's 2 pi over 3. This would be 4 pi over 3. And another 2 pi over 3 would be 6 pi over 3, which is 2 pi. Okay, so this is just going to be how I'm going to get out to 2 pi and show all the wave, the whole wave that they want us to show. We're going to do one cycle from here to here. Okay, this means this is where one cycle occurs within from 0 to 2 pi over 3. So we're going to split up 2 pi over 3 in half. What is half of 2 pi over 3? Pi over 3. I think somebody's already gone further. I heard a pi over 6, which is half a pi over 3. Oh, that's okay. Same, and that would be pi over 3. Here would be pi over 6. 1 pi over 6, 2 pi over 6. Next one would be 3 pi over 6, which is pi over 2. I'm reducing in my head. Boy, that's a lot of labels. All right, now I'm going to go ahead and sketch a sine wave from 0 to 2 pi over 3. Now, what's my amplitude? Okay, my amplitude is positive 1. It is 1, always positive. So I'm just going to draw up to 1, down to negative 1. Okay, now I'm going to graph it, and the sine wave starts at 0, so we'll still start at 0. We'll go all the way at pi over 6. We're hitting up at 1, back to 0, down to negative 1, and back to 0. Sketch it. Okay, and the next step will be to label your 5 key points in that one cycle. The first one's 0, 0. The second one is pi over 6, 1. The third one is pi over 3, 0. The fourth one is pi over 2, negative 1. And then the final one that you need to show would be, I don't know, I'm going to write that. I think I'm going to continue my graph first before I write that one down. I'm going to keep chopping this up. I'm going to cut that in half. And then I'm going to cut this in half and then those in half. And I'm going to think about how I could label these. The more you understand what I'm doing right now about getting these labeled, it's going to help you with, it helps you with doing the unit circle labels, and also helps with getting these axes labeled. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. What would be next? 5 pi over 6. Yes? If I need them labeled, then they're going to need to be labeled. Is that what you meant? If we're going out to here, we should be able to label any point. Oh, do you mean all these? These? No, only 5. I'm not going to label any more points. I'm just going to label the axes, okay? Now, I think I misunderstood what you were asking me. 5 pi over 6 pi over 6 would be pi. Then would be 7 pi over 6. So if it doesn't reduce, you label it. 8 pi over 6 would be 4 pi over 3. 9 pi over 6 would be 3 pi over 2. 10 pi over 6 would be 5 pi over 3. 11 pi over 6. And bang, then I hit the 2 pi. Okay, all I'm going to do is continue the graph. And you're not going to have to do this many labels very often. And you won't have to, you'll only be labeling 5 of the points within the range that you're asked to graph. Just keep following your little pattern. Oh. That's a lot of writing. Okay, so what's next here? I believe it says something at the bottom there and asks you, wait, let's get back to where your worksheet is. If I have this here, yeah. If b is a positive number, the graphs of y equals a sine bx and y equals a cosine bx will have an amplitude of the absolute value of a. Okay, so why did I say absolute value? That's right, Olivius and Melanie said right away, because, and I'm thinking maybe somebody else did too, a is always positive. So that's why I'm saying absolute value, because, what do you think happens to a graph if a is negative? What did it do before, like a parabola? It flipped it, right? So this is going to flip it. If a is negative, it's going to reflect over the x-axis. And the period is found by taking the normal period, 2 pi, divided by b, which is basically, the pattern is old period divided by b. So say if you were doing a tangent or a cotangent graph, they only have a period of pi units because they repeated faster. Their periods, new periods, would be the old period pi divided by b. We're not doing hardly any of those. Okay, we're really just doing the sines and cosines. All right, we got some more we're going to practice here. All right, graph one complete cycle of y equals 1/2 x. Ooh, we haven't had a b that was a fraction yet. So here b is 1/2. What's a? Okay, 1. So the amplitude's 1. And the period is, okay, we got to figure that out. 2 pi divided by 1/2, which would be 2 pi times the reciprocal of 1/2, which is 2, making it 4 pi. So what happens is if your fraction, b is a fraction, you have less cycles. Like you can cut the cycle, you only have half of a wave up to 2 pi. It made the wave take longer to complete. So it stretched the wave horizontally, right? Yeah, we're going to need 4 pi at the end of the graph here. Yep. Now, this is nice to cut in half, because if this is 0 and that's 4 pi, half of that's only 2 pi. And half of that is 1 pi. And now our x scale, or a scale on our x-axis, is by pi units. 1 pi, 2 pi, and then between here would be 3 pi. 3 pi. Oh, what did I just do? Oh, my lordy. Goodness gracious. Sorry for my strange oh my gosh, I almost just did it again. Terrible. All right. 3. And I don't know why I have a pi in the bottom. All right, I'll get it together. I'm tired. It's 7th hour. And this week, didn't it seem like Friday yesterday? We had testing yesterday. That SAT take a little out of you? All right, our PSAT. All right, our amplitude was just 1. So we're going up to 1, down to -1. All right, is it a sine or a cosine? You want to go back and make sure you paid attention to that. It's a cosine. So cosines at 0 are not 0, they are 1. All right, so start up at 1. Oh, and if you feel like this would help you when you're doing your graphs, you can put in some boundary lines if you like. Just dash them. Because I know some of you are going to go wacky outside of your little lines. And it might help you if that's you and no, mine's not perfectly spaced, but it's pretty darn good for a full sketch. We started up pi. We're next coming to 0. I think putting in your dots first and not labeling anything is the easiest way to go. Like put in your points so you can kind of get those neatly labeled. When I don't mean labeled with their names yet. And then up to at 4 pi, back up to 1. So now you have that. Then do your curves. Not a V, Matt, which I just heard you say. No V's. Curves, please. No, it's not a curvy V. They're actually quarter of the circles in a sense, but they get stretched, so then they're not circular looking anymore. All right, let's label the points 0, 1, pi 0, 2 pi. I like it better when it's not so crowded, don't you? 2 pi negative 1, 3 pi 0, and 4 pi 1. How are you doing? Okay. What are you going to do if you say no? I don't know. I'm going to have to keep going anyway. But all right, here we go. Number 7. Oh, 2 things going on. Amplitude change and a period change. So the A value is 3, which tells me my amplitude is 3. My period is found by doing the old period, which is 2 pi, divided by the B value. And B is 2. So, 2 pi divided by 2 is pi. But look what it told us to do. It said to go from negative pi to 2 pi. All right. If we make this negative pi, and I did give you a way to do this, that'd be 0, and then about the same distance. That'd be positive pi, and then 2 pi out here. Oh, I didn't space that very well. Let me do a little better. I think I got this. I can put this a little further out. That wasn't much of a change. Oh, well. We're going to have how many cycles then? Yeah, because the period is pi, and we're going from 1 pi, 2 pi, 3 pi units. We're going to have 3 cycles. All right, so cut the pi in half. That's pi over 2. Cut pi over 2 in half. That's pi over 4. 1 pi over 4, 2 pi over 4. Between here will be 3 pi over 4. There's where one cycle is going to occur. This is a sine graph, so we will start at 0, 0. Oh, what's our amp? Up to 3, down to negative 3. Again, if you want to put in dashed lines, to guide you. I've had some students like to grab a ruler and do that. All right, let's graph. Pi over 4, we're up to 3, back to 0, down to negative 3, back to 0. Excuse me. Get my pen going here. All right, there we are for the first wave. Mine's not perfect, but oh well. I'm going to label these because these are the only ones we have to label with the names of the points. Be pi over 2, 0. 3 pi over 4, negative 3. And pi 0. And then I got to cut this section up. and continue my graph. We're going to go back up, down, middle, and all the way down and then back. Follow that wave. And if we went backwards, you actually label those just like you did the first 5, and then except 0, a negative pi over 2, negative 3 pi over 4, and negative pi over 4. And I don't like going backwards very much, so I like to go, hey, well, I'm going to almost have a whole new cycle from here to here, so I don't graph as pretty if I go from right to left. More power to you if you do well with that. Anybody still need this? Oh, I didn't finish labeling today. Okay, if I do by pi over 4s, let's practice counting by pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 3 pi over 2 is what it reduces to, and then 7 pi over 4. What? Yeah. To do all the pi over 4s, you go every 45 degrees. Like if you were doing the unit circle, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Yes, it is. That's why I was going to say that. You just jumped, you got me before I did. 6 pi over 4, 7 pi over 4. There, you're done with that one. If you do your 1 pi over 6, yeah, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Yep, that's exactly how I tried to show you when we learned how to label the unit circle. All right, let's move to the next graphing. Good, I'm hoping you're realizing that this is going to help you with your labeling, can help you with your labeling on the unit circle tomorrow. All right, we got an A of 4, which means the amp is 4. We've got a B value of 1/2, which means the period is now 2 pi divided by 1/2, which is 2 pi times 2, or 4 pi. All right, here we go. It says for us to graph. Wait, what was my amplitude? 4 to negative 4. Pardon me? Oh, this isn't even, is it? Is that what you're saying? You're right. I should probably make that. It would look better if I. Oh, that was too far down. He's saying that, yeah, I don't have my arrow thing is even. So if I wanted to be a little nitpicky, I probably should even that out. But I will not be that nitpicky on your graphs, okay? I'll lower that just a little bit to make Zach happy because I think it's going to bother him. All right. It's still not perfect, so that kind of bugs me now. All right, that's enough perfection, right? Okay, here we go. Wait a minute, how convenient. We're supposed to go from negative 4 pi to positive 4 pi, and the period is 4 pi, which means we're going to do one cycle to the right and one cycle to the left. All right, we got 0 in the middle. Half of 4 pi is 2 pi. Okay, break that up. We're going by our x scale is pi units, 1 pi, 2 pi, 3 pi. And then, of course, back here, it'd just be the exact same values except negative. Bless you. Okay, cosine or sine, better check that. Cosine. So we're going to start high, go to the x-axis. Oops, that font was a little large. Okay, the first wave that you have to label is the right side. Ooh, mine's a little over curved. Okay, 0, 4, pi 0, 2 pi negative 4, etc. And this should not have gone higher than that, so I should not have it coming back down. That's not right. Ooh, I really don't know what all that is. I haven't used that. Go backwards? Oh, I don't do well with that. So let me go. Oh, sugar, this should be up here. Oh no, I said sugar in my video. Oh dear. Naughty. All right, you don't have to label those. Now, I would like you guys to go to worksheet. Well, your assignment is 24 and 25. Oh, I did forget something just now. There was another question at the bottom, correct? All right, at the bottom of your worksheet, 24 and 25, but I'm going to do a couple graphs before we go. Now, what's the amplitude? You've got y equals 5 sine 2/3 x. So the amp is 5. The period, well, I got to take 2 pi divided by 2/3. 2 pi divided by 2/3 is 2 pi times 3/2. Max? Cancel those. The period is 3 pi for this one. This is the kind people don't do well with, so might want to pay attention. All right, the second one says y equals 3 cosine 5x. That's an easy one. So the amplitude is 3, and the period is 2 pi over 3. My pen just went wacky. 2 pi over 5, excuse me. All right, 23. Check if I have that up. I don't. No, I was going to do phase shift. Here we go. I better pull up a blank one of those. Let's look at number 3, please, on 23. What do you think you should do? Look at number 3 on worksheet, 24. Look at number 3. What's it say at the top? Transformations. Trig. You're going to reflect it. So it's going to be the same graph. Now, these are kind of nice because they already have the grids here for you and they're semi-labeled. Some are labeled, some aren't. This would make this graph reflect over the x-axis. So if the amplitude, though, oh, what if I asked you, what is the amplitude? Aaron, what would the amplitude be? I was waiting for that -3. Amplitude's 3. The negative sign just reflects it. All right, it's a sine wave, so it's still going to start at 0, 0. But pi over 2, it's not going to go up. It's going to come down. Right, and then back to here. Then 3 pi over 2, it's going to be up and then down. Now, I will just graph this before I extend it and label my points. And then if I wanted to continue it, we would just come down to here. And you don't have to label that. And then if we were going this way, it would be back up to 3. Yes. You just don't have to put the point names on them. Just put the point names on within the 5 key ones in one cycle. You can't like skip, guys, and write this point as opposed to that one. You know what I mean? Do the 5 key points within one cycle. All right. I was going to look with you real quick at 5. Okay, so that amplitude here is just 1, but it's reflect. So that's what you always want to note when you have a negative number in the front or negative coefficient of the sine or cosine. The period is 2 pi divided by 3. You can't simplify that, so that's the period. So what I'd like you to do when you go to label now, I don't care if you want to put 1 up here. This would just have been 1/2. Okay, if you want to put -1 there, just make sure it's labeled. Okay, that would be 0. And then going horizontally on the X labels, if you have to do 1 key point, this is a sine wave, so we know we're going to start here. We need a second one, so let's go 1 key point, 2, 3, 4, 5. That's where we would want it to end. That's where I'm going to go ahead and put the 2 pi over 3. Because see, now I can do the markings that I just been doing with you today. So if I do half of 2 pi over 3, that's pi over 3. And half of pi over 3 is pi over 6. And we got 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. And now I'm ready to go. So I go to pi over 6, 1. I like to change the color just so you can see. And then pi over 3, 0. And I'm not labeling them yet. I'm just making my dots first. What? What did I do? Oh, sugar. I'm doing it as if there's no reflection. So guess what? If you did this, this would be like your ghost graph. Ah, so I have to now. Oh, you caught me before I did it wrong. All right, so I got to go down and then up. So if you graph one wave, this is what has happened to it. It got reflected. Perfect. All right, now what do we do backing up? Is it negative pi over 6, negative pi over 3, and negative 2 pi over 3. So it'd be one more cycle. Is it? 1, 2? No, I don't have a full one, do I? Negative pi over 2. Okay, have a good day.